Data architecture, making selective queries for performance. Today we're continuing on our data architecture series. We've been talking about the query plan tool, the query optimizer, and we were just recently talking about indexes. Now, in order to make a query and use an index, you actually have to ask for the data in a selective manner. What that means is ask for it in a format that will allow Salesforce to use the index properly. And there are only certain ways that you can use the indexes to get their advantage. Otherwise, as I showed in the previous video, it has to go touch all the records, which is a full table scan. So for performance, if there is an index, you need to ask for the data in a selective manner. And we're going to be covering that right now. In our previous video, I talked about standard indexes exist on these fields on custom objects and some standard objects. There can be custom indexes you can have created. These can be, if you open a ticket with Salesforce support, it can only be done on certain fields, or you can create what's called an external ID on a field of a certain kind, and it will create an index. So you can have a standard index or a custom index, which will allow the query optimizer, which I described as the librarian, to be able to utilize the index. And the query optimizer will choose whether it sees what you're asking for as a standard index, custom index, but it also needs to see the way you're asking for it. So what we're going to go over is requesting the data in a selective manner. And so a selective query is a query designed to use the indexes efficiently. This means that the query criteria are specific enough to quickly identify what rows without having to do a table scan. And it can definitely speed up performance, especially when there are large data sets involved. So you may be able to be just fine on a small data set, a few thousand, even 10 or 100,000. But when you start to go into the millions of records, this is when you need to be tapping into those queries and asking for it in a selective manner. So a selective query is one that utilizes it. So for certain data types, you need to use them properly. Now, created date, in this first example, created date is an standard indexed field. And if you give it a specific date and do a greater than, less than, or equals to, it will be selective. Now, the second one is account ID is a foreign key. And if you were to grab a number of children contacts based on a parent account, and a parent account ID, this is selective. So that'll be very fast. Now, if you were to have custom feed, now here you have stage name and close date. Now, assuming that you had created these as external IDs, which would work, created these as custom indexes with a request to the ticket, then it could work. So stage name is, as we showed before, is not a standard index, but could be one. Could be a custom index. And close date could be a custom index. So these are ways equals as a way that is asking for the data in a selective manner. Now, to be more clear, things that are not now, indexes start with the left character and move over. So if you were looking for Steve in Steve's plumbing, it would matching left to right. But if you try anything where you're matching in the middle, it cannot use the index. It needs to do a full table scan. So if you said and you can use the wild card, but not with the percent sign in the front. And that is the equivalent of using what's called a contains. So contains, bad, not selective. Starts with is good. And putting a wild card at the beginning is bad. And a wild card at the end could still be selective. Negative operators are not selective. Not equal to's, not like, not in, not exists. These are not selective. So these cannot use the query. Null searches, testing to see if it's null. That does not use the index, so that is not selective. And if you create a formula field, now you can create index, have Salesforce create a custom index on a formula field, but only if it's what's called deterministic. That means it won't change. Example, if you had a date time calculation in there that changed today's date, read any other value outside of the object, that would not be selective. So there are selective ways to ask and non-selective ways to ask for data. And again, you have to be asking on a field that has either a standard index or a custom index, and you have to be asking in a selective manner. Now, complex joins and subqueries have multiple objects, can also be non-selective. And if you have a high volume of records with a particular parent ownership data SKU, this could be non-selective. So these are the things that can take you out of a selective manner into a non-selective manner. Now we're taking a look at an org where I have an object, an airport object, and I have about 75,000 of them. So although it's not at large data volumes, it's got significant data. And what we're going to be doing is the name field is out of the box an indexed field, but there is another field called the ATA code, which is a text field, which is not indexed. So if we were here and we were doing a filter and we were adding a filter where, let's assume the name field starts with Z, this would be a selective index. So if we went save, then this list view is going to be fast. So this is a starts with on a name field. So it's an index, it's a field with an index, and you're asking for it in a selective manner. And the equivalent of that running in the query would be the name is like Z. So that is the equivalent of starts with. And we're going to execute this query, and we can also see from a previous one, the query plan analyzer, we can see that this has a cost of a 0.09. So that is asking for the data in a selective manner. Now, if I were to change this to contains Z, now this would be filtering the data in a non-selective manner. And so if I were to change this and put a % in front and after the Z, this would be the equivalent of contains, and we do the query plan. Now we're at a 0.69. So the cost has gone up dramatically. So let's get rid of this again and see from a 0.69 to a 0.09. So it's about almost, a tenth the speed. So 10 times as fast, 9 to 10 times as fast. So this is asking it in a selective manner. Start contains is not selective. Starts with is selective. I'm also showing you that if you were to do things such as equals to would be selective. Not equals to is not selective. For numerics, greater than or less than is selective, but if you're doing greater than or less thans on text fields, that is not selective. So as you use the list views, the report filters, how you're using them is important, and what field you're using them on is important. So you need to be asking for it in a selective manner, and you need to be asking it on a field with an index. So as you have objects that have a number of records approaching hundreds of thousands or millions of records, and you're making queries, you need to be going through the checklist. Do I have an index on that field? And am I asking for the data in a selective manner? There's one more part we're going to talk about in another video where we're talking about the selectivity threshold. But right now, you're feeding this information, you're asking for the data, then the Salesforce Query Optimizer, the librarian, will be looking at the data and deciding whether it can or cannot use the index, and then it'll either be a fast performant response or a slower response. So I hope this was helpful. In future videos, we're going to dive into the selectivity threshold and also start looking at more details about indexes and queries. Hope this was helpful. Thank you as we're selecting for success. and have a great day. Thank you, and subscribe to www.SteveTechArc and SteveTechArc on my YouTube channel.